Okay, so we're going to look at how to convert from standard form to vertex form with a quadratic using completing the square. And I want to illustrate this using our area model, but also using some algebra tiles. So first of all, we're going to start with this parabola, the quadratic y equals x squared plus 6x plus 3. And we'll model this like this. There's our x squared. There's 3 x's, there's 3 more x's, so that's 6x. And then we have plus 3, so there's our plus 3. What we want to do here, though, is we want to complete a square. In other words, we want to get some binomial squared. Now, in all of these examples, you'll notice a already equals 1. So we're not going to worry about that here in Algebra 1. But what you'll see is by completing our square, that will also end up giving us the k. So what do we mean by completing the square? We're going to take this and rewrite it so that it looks like this, a perfect square, something squared. So let's start first of all by arranging our terms. Now, as we learned to factor using the area model, we put x squared here in that first term, but this time we're not going to put the 3 in that box on the bottom right. And in fact, I'm going to actually ignore the 3 for the moment, okay? Because I want to actually create a perfect square. I want this, whatever this is, to equal something squared. That's my goal. So if I model this here we can actually see the square that we're trying to create. I'm going to have these 6 x's and I'm going to arrange it in a square so that I have this side that is x units long plus 3 more units. And then this side is also x units long plus 3 more units. And you actually can see that shows us what our area model should end up looking like, x plus 3 and x plus 3. Now you'll notice I don't have an actual square here. I'm missing this corner. So to complete this square, I need to figure out how many 1s will go in there. Okay, so if I look at my area model, you'll notice I have 3 x's here and 3 x's here still. And notice what I ended up doing. I ended up splitting up that 6x evenly. But our area model shows us very clearly that we have 3 times 3. I need 9 units to actually complete that square. And if we do this, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And while that isn't absolutely perfect, you can see that that 9 units would then complete this to make it a perfect square. Okay? So that's the visualization. But I just added 9. I can't just add 9 because it's convenient. I have to add 9 here, but I have to also balance that out because we're not allowed to just add 9 because we feel like it, but what we can do is add the identity. And the identity is 0. The identity for addition is 0. And since I added 9, that means I also need to subtract 9. So I'm going to take 1, 2, 3, 4, 5, 6, 7, 8, 9, and subtract that. But when I put it together with this 3 that I had originally, 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0. There's a 3 minus 3. So what I end up with is negative 1, 2, 3, 4, 5, 6. And you can see here, after completing the square, I have x plus 3 times x plus 3, and then the 3 minus 9 gives me a negative 6. So that would be the vertex form of this parabola. Okay. Let's try another example here, dealing with x squared minus 4x plus 7. Okay. So let's set this up. We have x squared. Here is 7, and I need minus 4x. So here's our negative x's. And again, as we look at our area model, we're going to take our x squared, but to actually create something that has a square shape, I'm going to take 2 of the minus x's there and 2 of the minus x's there. And you'll notice what I have now is across the top I have x minus 2x, or x minus 2, because there are negative 2 x's right there. And then down the side, I have x minus 2 as well, because I put negative 2 x's there. So that has to be an x, and that has to be a minus 2. And if you multiply it back together, x times x is x squared. Negative 2 times x is negative 2x. Negative 2 times this x is negative 2x again. But what do I need to complete this square? I need 4, because negative 2 times negative 2 would be 4. So I'm going to add in 4 units here. And notice again, I'm ignoring that plus 7 that was in the original problem. I just leave that off to the side while I complete the square. In our equation, it would look something like this. We're adding something, and that plus 7 is off to the side. So here, the plus 4 will complete this square, making it x minus 2 squared. But to balance out that plus 4, I also have to subtract 4, so that my identity, again, the identity is 0. I have to subtract 4. So if I subtract 4 over here, notice there's minus 4. That will make a 0 with this plus 4. Those are all gone, and notice what's left. I have a plus 3. So now I have vertex form. Okay. Now, algebra tiles can be helpful, but they are limited, especially when we have something like this. But notice the pattern. Every time we're doing this part here, we end up taking this middle term, the 6x in this case, and splitting it evenly. Here we took the minus 4x, we split it evenly. So even when we have an odd number of x's, we have x squared, and we have a plus 5x, we can split that evenly into 2.5x and 2.5x. And you'll notice what I'm doing here, I have x squared plus 5x. I set aside the negative 10 for now. And what I'm going to end up with here, if we look at our area model, this is x by x. X times x is x squared. To get a 2.5x, I'd have to multiply the x by a positive 2.5. And same thing down here, I'd have to multiply the x by a positive 2.5. So, in the end, what I'm going to end up with is x plus 2.5 squared. But what did I have to add to get that? Well, here we have to do 2.5 times 2.5, and that's a plus 6.25. If you multiply 2.5 times 2.5, you'll get 6.25. So that's what I had to add here. And that means I also need to subtract 6.25 to make that identity 0. So I'm going to do that right up here as well. So minus 6.25. So now I already had the minus 10. I'm going to subtract 6.25 more, so that's minus 16.25. And that's how we can use our area model or algebra tiles to convert from standard form to vertex form.